Hello guys, in this video I will show you how to create application software to calculate two-dimensional projectile motion. Okay, two-dimensional projectile motion. When you say projectile motion, in general we may have one-dimensional motion. Okay, it is along x line or y line, it is line motion, or it two-dimensional motion, it's plane motion, which means it can be defined by both x and y. And 3D motion, it is space motion. That means it can be defined by three Cartesian coordinates axis, that is x, y, z. And also we do have in higher level, we do have also four-dimensional projectile motions, in which case the motion is not only space dependent or spatial dependent, but also it's time dependent. Okay, I think it is enough as for introduction. Our aim is to show you how to create the application software by using FORTRAN FTN95. Okay, so how can we create by FORTRAN 95? This is the important part. Okay. Our main topic is what? Our main topic is projectile motion, 2D projectile motion, 2D projectile motion, 2D projectile motion by FORTRAN, FTN95. Okay, now the general equation for projectile motion is S. Okay, it is equals to displacement is equal to initial velocity ut times time, okay, plus a times t square. Okay, it's a times t square. Okay, t square over 2. Now how can we write the script? This is a question. Let us write the script. The script will be like this one. Okay, first we know that we have said that for FORTRAN we always write program in the beginning for free FORTRAN format. Program. Okay, let me call displacement. Maybe displacement, or let us make it easy, S. Okay, S. Then the second is implicit, none. Okay, let us say none. Then again, after implicit, we will define whether integer, real, or something. Let us say integer or real. Let us say it's real. Okay, real. Okay, real. What are the elements real? U, T, and UT and S. But we should change the name. Okay, the name and the variable should not be the same according to the principle of FORTRAN. Instead of S, let us say again displacement. Then after this, what value should be we want to be read? Print. Okay, print. Let's print. After print, asterisk, comma. Again, there is what? Quotation. Okay, let us put quotation here. Where is quotation? Yeah, here. Quotation. Then let us say enter. Enter say u comma t comma okay, and a. Okay, here there should be a here, because say let me insert a because we need a as a variable. Then do put column and then again quotation. So or also you can leave enter here, okay, according to your interest. Then the second is read what? Asterisk. You know, asterisk is a code. Should not forget code. Asterisk. Without asterisk, no communication. Asterisk. Okay. Read what? U comma T comma A. Then write equation S is equals to ut that means u asterisk means multiplication, asterisk times t plus half means 0.5, okay, times asterisk, okay, a times t power of 2. Then again, now print. Okay, I'm writing here for your understanding before we go to the actual application. Print S. Print S. Okay. Print S. Then in the program. That's necessarily okay, you should say in the program after that. Program English should be in the program. In program. Okay, this is the script, this is the equation, okay, 2D projectile motion by FORTRAN FTN. S is equal to ut plus a times t is the power of 2. This is the power of the computer, okay, computer language divided by 2. Script program ds, okay, in the program here ds or displacement. In this manner you write script, okay, program this plus implicit none real UTAS, okay, all should be real. Print this one asterisk, okay. Now let me try to copy this one again. Once I write this one, I can copy. Okay, I'll copy it. Now I'll go to what? I'll go to, as usual, I'll go to this one. look, this is Plato. I'll click the Plato. The Plato will open. See the word Plato. Let me adjust for it to be inconvenient way, to be convenient, to be observable. Okay, next, what shall I do? Next, I'll go to normally file, new. Okay, sorry, file, new. Okay, here, project, then FORTRAN here, FORTRAN application, the project here. Okay, there are different projects actually. If you go to file, new, file, okay, this will be detail, because it is a project, it is a new file, about the new file. So what I did here, don't forget, I go to file, then again new and file. Okay, that's fine. You'll get this dialog box. Okay, after that, click this one, new, free format. Okay, then I got this dialog box, which is a blank area. Okay, now what shall I do? Let me paste. Here's pasting. Yeah, we got what you have written. Yes. Then what shall you do? Next time you go to build, okay, and run compile. It says, let me save it. Where shall I save it? Okay, let me do it for desktop for other time. Okay, create new. Okay, here, create new in the desktop. Okay, let me change this name. Displacement. This P. Okay, this P. This P. Yeah, I got this one. Yeah. Yes. And okay, I'll save it. Okay, I'll go to save. Okay. Yeah. Ooh, a lot of errors. What is that? One. I'll go to here, check, click here. It says that a separate is required after implicit with free format. Implicit, okay. I grab it. Call error. Okay, instead of implicit, remove a. Okay. Then I'll go to again to compile. Go to compile. Okay. Many things is adjusted. Second, you go to end checkup. I'll go to the error again. Error. It says illegal character of illegal character combination. This one. Okay, here again I used comma. It should be 1 comma. Okay, let me go again, build and compile. Okay, look, the number of errors is going to minimize. Okay, number of errors minimized. Here again, I'll click here. It says column found where is not expected. Where column here? Where is column? Yeah, here column is not required again. I will remove this column. Okay, I'll go to again build and say compile. Look, the number of here, the number of errors going to be from 4 or 5 to now become 1. What does it plus? I will click here again. Click. Unexpected. This one is expressed. Well, which one? Okay, what should be? This should be adjusted. Let me adjust. Okay, it's not a simple task doing program. Okay. Instead this one is 3 equals to 6 here. Okay, I should use shift. Okay, it's 3 8 in my computer. 8, yeah. Let me do again build. Second compile. Wow, it's compilation. What's this one? No what? No compilation completed with no error. The variable has been given a value but never used. Okay. The variable s has been given a value but not used. Where? Variable s is given. Here is real. Okay, may I remove this one? But you don't use this one. Okay, the variable u is given. Let me again go to compile. Wow, implicit has been used. So let me adjust again. S. Wow. Let me go to and compile. Yeah. So where we used? Okay. Enter s. Okay. S variable. The variable s has been given a value not but never used. Where is it? Let us see again. Why I should not remove? I should not ignore this. Here. Here, look. Remember you. In the formula there is u, there is t, okay, plus 0.5 times a times t, okay. But the variable s has been given a value but never used. Okay, it says that you have given the opportunity. It's implicit, it's not implicit in none, it's a real number, but you don't use it for print or either the print or the read. You know what, right? It's actually nothing, doesn't affect our problem. Okay, let us go. Now the second step is let us build. Okay, what does it say? Look. Okay, here the compilation and the linking completed. That's satisfactory. So the third step is go here, build, start. The program, this bar is observed here. Okay. After this, in the dialog box, this is the application. We have now we have been able to creating this software. So to change the background, go to edit or property, and let me change this. I like this color. Okay, so that if I remove this, okay, let me work. Yeah, have you seen this? Our background is changed, attracted by this one. The equation is here. Now enter let us enter 10 for you, and you can test by yourself. 2 seconds the motion, so the acceleration is again 10. What is the displacement? Oh, still there's something. Okay, let us go back. Okay, let us make this one equal, some times still equal, and here is comma and s. Okay, let me run. Let me show you how to happen. The executive is out of date. Would you like to build? Yes. Okay. This license not validated, no committed, use this universal. Okay. Now, it becomes attractive and clear now. Yes, of course. Look this. Now let us again do the previous one. The initial velocity is 10. Time is 2 seconds, and acceleration is 10. Oh, is it true? Yes, let us check that. You always, when you create a software, you should check by your hands. Distance is equal to, or displacement is equal to u times t plus half of 80 square. Okay, u is given here, u is 10. It's according to the order. Look, according to the order, this u first, second, time, third. Okay, it's according to this order column, this one. So u is 10 given, t is 2, acceleration is what, 10. So s is equal to u times t, 10 times 2 plus half times a means 10 times t square means 2 square. Okay, initial u times t 20 plus half times, okay, half times 10 times 2 raised to 2 means 4. 10 times 40 divided by 4, 40 divided by 2, it is 20 plus 20 give us 40. It gives us 40, so it's correct. Okay, we have now finished how to create the important projectile, two-dimensional projectile equation. Okay, actually it is challenging because it requires your knowledge of computer, how to script, okay, and how to handle when error occur, how to remove the error. Okay, you have seen that in first step when I compile, okay, there are a lot of errors appear, almost 6 errors, but I remove one by one by using click at the error point and then go to compile and minimize. It becomes, at the end, it becomes 0. But in the case of the build, there is no problem because the software by itself is normal. It is normal software, so building is not a problem. So that once we adjust and get building and compiling, we go to run. By running, we get such type of software. This software is very important. I will show you now how can we use this software after this one. Okay, here read this one, press return to close the window. If I want here, okay, I will close. Okay, I will close. By what? By clicking return key in your computer. Oh, let's go away. Now let me save this one again. I should save this one because I have corrected a lot of mistakes. Do you want to replace? Yes, I want, because it's now correct. Okay, if I want again, let me repeat once for you what I did. I write the script from my then I copy and paste it. Okay, when I run by clicking build, I compile the script, but a lot of error has been observed. I remove each error one by one by clicking at the beginning part of this one, the errors indicating this one. Okay, then after that, what I did, after removing each error, I go to build and build the software. Okay, by linking. Okay, by linking. Okay, I link it. So the linking is completed and the compilation is completed. If the linking and compilation complete once, what you are going to do is that you will go to build and run. Start running. When you start running, you will get a dialog box that shows something. Okay, yeah, like this one. There is this bar. It comes, okay, repeatedly. It tells you for whom it is easily available. Okay, now for example, if you want to solve another problem, let me enter. Okay, you can create by yourself the application software which can solve initial velocity, you can solve the acceleration, so on. Okay, this is a typical example how to create application software by FORTRAN. Okay, FORTRAN application software for FORTRAN to calculate what? Displacement. Okay, let me do another example. Say if instead of it is using the motions for acceleration in free fall, the previous example is not gravity, is not involved. We assume that motions under vacuum, no gravitational force, or in space where the gravitational acceleration is ignored. But in a real condition, accelerate when you are throw a ball on space, okay, in a plane or in space, okay, the motion of the particle or a body is governed by a natural gravitational force. So the motion of the particle, okay, is under gravitational equation. So let us assume one example. Okay, instead of 20, u is 20 for example, and assume accelerated time is say 1 to simplify the matter, and acceleration is, we know it is, for acceleration is negative 9.8. okay, what is the displacement of the particle? Let us enter. It is very fast. You get 15.11. you can check by your hand. Okay, S displacement is equal to ut plus half of 80 square. Okay, u is 20 times 1 plus negative 9 point this one times t square. Okay, t square 1 square. Okay, 2 times 1 is 20 plus, okay, 1 square is 1. Negative 9.5 means when you divide this one, it will be almost G 9.8. 98 by 2. 82 by 4. 4 times 2, 1, 18, 9. Okay, it is 9, 4.9. okay, 4.9 by 2, 18. Again 9. Okay, 999. Okay, if you have simple calculator, you can check it. So when it is approximately 99, okay, it's approximately 15.1, almost 50.1. okay, so without any difficulty we can solve. Once you create application software, calculating by your hand will be as such significant, will not be as such significant. Okay, let me show you again. Now I have cast, for example, now I have created once this application. Okay, I have written this script, as I have shown this script. This script has a lot of problem, but once I have got this script, I can move down this script and let me go to wow, display. Where is the displacement? D part, D folder. Maybe challenge for me now. It's not as visible, guys. Yeah, look at this one. Oh, here. This is our application displacement, error log, build. Okay. Sorry, everything I'm not on the same folder, but it should be in the same folder. Let me click this one. Yeah, I got this application. Look, I got this one. So it's after this. If you want to change again to be more visible, you can do like this. This what as I have done. Okay, cancel and click this again. Yeah. Okay. Yeah, this is application. Okay, this is an application. The end comes satisfied. Okay, this is application software for displacement. Now again, let me show you that the speed is 50. Okay, for 500, for example, 550. Okay, the time is, for example, 56, 57. Okay, I can. Acceleration is maybe, okay, negative, say negative 9.8. As usual, what will be the result? 9.8. what is sorry. Oh. Okay, I will repeat once again. Sorry, excuse me for losing of my current activity. Let me give you a big number, okay? Everything is not easy in creating. Let me give you a difficult number. 956. This number is initial speed, okay, and the time I say 3 4, okay, but the acceleration is negative 9.8. What will happen? Okay, you may be eager to see. Let me enter. I don't know why this tells me. Okay, let me try again. 20, 2, 5. Okay, there is a problem. What should be the problem? Okay, the files is distributed here. Okay, instead of that, okay, sorry guys, excuse me, go to, instead of using this one, go to Plato. Yes, go to Plato. Okay, yeah, I've seen that this has a problem. I'll go and reopen this one. Open what? Open the file in the desktop. Where is the disk? My computer is team. There is here. Yes, I got this one. Yeah. Okay. So let us see. Data states 20. Yeah, we are testing now. 20. 4 and okay. Yes, it's okay. Okay. Look. To use this application, from my experience, I've seen that. Okay, I've seen that it's better to open by Plato. Okay, if it's not open by Plato, it will be disappear once it's open. But when you ask it to execute, it will disappear. So the file is important to store. The application is stored in one file folder when you are create. Then when you want to use that, call by using Plato. Like this is what I did, but looks important, very great, important, very great. Okay, once you call like this one, okay, go, okay, run like this one, because it is non-licensed for research and all and commerciality. Okay, it is only not licensed, don't confuse. Now the importance of, even if there is complexity, okay, the importance of creating this application is when you are doing in physics a very large numbers, which will be tedious to calculate, to multiply, to divide it. okay, application is okay credibly very valuable. Okay, it is very invaluable. It is very invaluable. So let me show you one number, a great number for that. The motion of electron. This may be initial velocity of the initial velocity of the electrons, and the time required to see this much of second. The acceleration may be like this one. Okay, you may ask to calculate the displacement. Okay, if you are asked the displacement, the result is this much of 1 plus this one. Okay, so this application has a great, very important to know. Let you do by yourself, by your hands, this one. Multiply this by this one, plus this one. But if you are using these calculators, the mistake is 0, because once it's created to accept the input. But when you are using calculators, you may miss something and do something. Okay, so it's better to use this application and creating other application for your exercise. See you guys. I will join you in another video. For the time being, it is enough. Bye bye.